time has come to talk about integration by parts, henceforth known as IBP. Integration by parts comes from product rule for derivatives. Recall from calculus 1 that if you're taking the derivative of a times b, you get this mixed result where you have a times the derivative of b plus derivative of a times b. Now if we take that and we look at, okay, what does that mean in terms of antiderivatives? We can do the flip trick that we always do when we're looking for antiderivatives, which would mean that there's an antiderivative rule here, which would be that the definite integral of a times db dx plus dA dx times b dx is equal to a times b. And we want to clean this up a little bit, so we could rewrite this as the indefinite integral of a times db dx dx plus the indefinite integral of dA dx b dx is equal to a times b. And what integration by parts actually says is that we're going to subtract over one of these, and it doesn't matter which one it is, but I'm going to rewrite this as the indefinite integral of a times db dx is equal to a times b minus the indefinite integral of dA dx times b dx. And usually people will look at these canceling, this dx is canceling. So how you're probably going to see integration by parts if you're using the letters a and b, the indefinite integral of a db to ab minus the integral dA. So this is pretty much pattern matching, and the question is, how do you know when to use it? Well, you know to use it when you have an indefinite integral of something that is multiplied by derivative of something else. Let's look at trying to find the indefinite integral of x times sine of x dx. Now this is sort of a classic integration by part problem because I have something multiplied by something else, and now I just want to try to match these pieces up in a way that makes sense. What I'm going to try to do is I'm going to trust that it's written in the right order. It might not always be. Let's say that a is equal to x and that b dx is equal to sine of x. What would that give me in terms of the other pieces? Then I would have the derivative of a, which would be x is equal to 1, and the antiderivative of sine of x is negative cosine. So now I plug this a, b, all these pieces into the pattern, and the pattern is that this is a times db, that this is equal to ab minus the indefinite integral of dA times b. So my a is x, my b is negative cosine of x, minus, and I have an integral here, and my dA is 1 times b, which is negative cosine of x. So now I have this, and I can take this and see if I can simplify. X times negative cosine of x is negative x cosine of x, and then minus times minus is plus, so I have the integral cosine of x dx, and then take this, the integral of cosine of x dx is sine of x plus c, so this would be negative x cosine of x plus sine of x plus c. And this would be my final answer for the antiderivative of x times sine of x. Let's look at another example here, which is I'm looking at the antiderivative of x times 3 to the x dx. So I'm going to try to fit this pattern here of a is x and db, and I'm going to stop writing db dx. I'm just going to write db. db is 3 to the x, which that means that dA is equal to 1, and that b would be equal to 1 over natural log of 3 times 3 to the x. And there's a plus c that should be here, but we don't worry about it. We just need an antiderivative. So this is my a times db part. On the other side, I should have ab minus the indefinite integral of dA times b, which I kind of like because it looks like dab. I can remember this as adab, ab, dab. So I have x times 1 over natural log of 3 times 3 to the x minus the indefinite integral of 1 times 1 over natural log 3 times 3 to the x dx. Now, I'm going to work on cleaning this up because this isn't done. So I can rewrite this as 1 over natural log 3 times x times 3 to the x minus, and I can pull this 1 over natural log 3 out front, the antiderivative of 3 to the x dx. And this is actually kind of interesting because I'm going to take this antiderivative. I already have this 1 over natural log of 3, but the antiderivative of this whole thing is 1 over natural log 3 to the x. So this would simplify to 1 over natural log of 3 x 3 to the x minus 1 over natural log 3 times 1 over natural log 3 to the x plus c. And this would actually be my final answer. If you want to, you can take the derivative of this and check that it actually works. We won't do that for this moment.